Hello everyone, good afternoon. I hope you are doing well. Today we have a very important lecture which is eigenvalues and eigenvector, and it's very important regarding your exam. So I can set from now that one question is there in your exam from this topic. So tomorrow is holiday, so we don't need to miss our week. So I'm recording this lecture for you from now, and so you can watch it, and then if you have any issue, problems, so we can discuss it. So we can start from the eigen. Here in this, we will use one main equation. Keep in mind this equation we will use, which is called characteristic equation. Throughout this topic, we will use this equation, which is characteristic equation. For example, I have a matrix. First, we'll start from 2 by 2, then we'll move to 3 by 3. For example, I have matrix 2, 1, 1, 2. And they ask us that find the eigenvalues for it. So first we will find eigenvalues. Find eigenvalues and eigenvectors. So solution. As I told you, the formula is here. A minus lambda into identity matrix is equal to 0. So now you have to write A. This is your A matrix. To write 2, 1, 1, 2 minus lambda. Lambda is lambda. And you all know this is identity, so 1, 0, 0, 1, which is equal to 0. Next one. Now you have to simplify these two. So we can say that A minus lambda is equal to 2, 1, 1 into 2. And minus lambda will multiply inside, so this is 0 is 0, this is 0, and this will become lambda, and this will become 0. Now simplify it more, multiply this here. First row, first column, then first row, second column, then first row, like this. So once you, no, sorry, this is not multiplication, this is just subtraction. So you will just subtract these from each other. So you will write here, it's 2, this is minus, so this is lambda, lambda will come lambda, 1 will come 1, and here 1 will become 1, and here it will become 2 minus lambda. So this was your step 1. Now we will move towards step 2, which is which we call compute the determinants. compute the determinants mean we have to find the determinant of this equation. So determinant of a minus lambda I, so you remember like this one, cross multiplication. So you can write 2 minus lambda into 2 minus lambda, and this is minus 1 is equal to 0. 1 into 1, 1. So we can get 2 minus lambda whole square minus 1 is equal to 0. Now we will move to the third step. I mean, we have to expand this, we have to simplify it more. Expand. We have to expand this equation. So once we expand, we can write here 2 minus lambda square minus 1 is equal to 0. And now let's look like if you remember in your high school, you have see this type of formula, which is equal to a square minus 2ab plus b square. So we can write it in this form. So here we can say that here a is 2 and b is lambda we have. So 2 minus lambda, we can write it like this: 2 square minus 2 into 2 into lambda plus into lambda square is equal to 0. Same, that's a square, this is 2, into a is 2, b is lambda, and plus b square, so which is lambda square. So now simplify this equation. So this is 4 minus 4 lambda plus lambda square is equal to 0. Now simplify it more and put it back in this determinant value. So what we will get? 4 minus 4 lambda plus lambda square, put it in the bracket, minus 1 is from here, so write minus 1, which is equal to 0. If you simplify it more, we can add another step. We can say simplify it more. We can write step 4. It's up to you if you want to add steps, not just these, but this is how you can simplify it. So we have minus 1 is outside from the, if you look at here, we have minus 1 here, which is outside from the bracket. So how we will simplify it? We can say that subtract minus 1 from the both sides of the bracket. So you will get this one plus lambda square minus 1 is equal to 0. We can write here, subtract minus 1 from entire equation. Then let's simplify it more. Why we are simplifying it? Because we need to find the value from here, from the lambda 1, lambda 2. So that's why we will simplify it as much we can, so then we can get the values for this lambda. And once you reach here, so we can say that now we can rewrite in standard form. And once you rewrite it in the standard form, what you will get? Lambda will go like this, lambda square minus 4 lambda. We just rearrange the equation, we put it in the standard form, which is 0. Now here we need to do factorization. We have to find a number that means we add, we can get, once we multiply, we can get, sorry, I wrote this equation, and you will simplify it. Yes, it's correct. Now we need to do factorization. So now we need to find like a number once we add those two numbers. So we will get this value. For example, lambda will come lambda. It will come, and this is 4 minus, let's say 4 lambda. We can write here plus 3 is equal to 0. Now this equation simplify a bit more. Now this factorization will come here. We need a number once when you multiply you will get 3, and when you add you will get 4 from two numbers. You know this is factors. So once you multiply these numbers, so you can get this lambda minus 1 and lambda minus 3 is equal to 0. When you multiply them you will get 3, and for the other one you will get 4. So now this is the factorization for this one. So once you reach here, what next you have to do? So just simple, if you look at here, lambda minus 1 is, you can say, is equal to 0, and lambda minus 3 is 0. So you can write your lambda 1 is 1, your lambda 2 is 3. Next, once you reach here, this is what we call this is eigenvalues. Now next one we have eigenvectors. Now for the same equation we have to find eigenvectors. We already find values. So we have lambda 1 and lambda 3. So now we can write here for lambda is equal to 1, and the equation you know that. When you are doing for the eigenvalues, we don't have the value for the vector for the lambda. Now you have value for the lambda, so just you need to put the value for the lambda. So your A matrix was, if you remember, 2 1 1 2, and we did minus lambda and 1 0 0 1. So it's 1, so you can, once you want to solve it, and x is your xy, which is equal to 0. Once you simplify this, you will get 2 minus lambda 1, 1 into 2 minus lambda, xy is equal to 0. Now put value for lambda is equal to 1. So 2 minus 1, 1, 1, 2 minus 1, x into y is equal to 0. So what is your equation now? 1, 1, 1, 1. Xy is equal to 0. Now, once you reach here, what you have to do? Now you have to put it in the equation. You know this is 1, so we cannot write 1. What we have to do, just we have to write x plus y is equal to 0 and x plus y is equal to 0. So both are same, we just need to take one equation. For example, this is equation 1 and this is equation 2. So now both are same, you just need to take one equation and put it in the formula and get the values for your eigenvectors xy. Now, once you reach here, so I took this equation x plus y is equal to 0, and I can write this equation like this. I move y the other side, x is equal to minus y. Why? Because I need to find the value for both x and y. So I will use here cross multiplication method. For example, now this is my equation, which is x is equal to minus y. Now, and keep in mind that both coefficient values has to be positive. I have one negative here. So what I need to do? I need to divide it by minus 1. So can I do like this? X into minus 1, and here it will become minus 1. So I can write here like this. So x by minus 1 is equal to y by 1. So this is x, this is y, and my vectors are x is minus 1, y is 1. So this is for lambda is equal to 1. Now coefficient, this only this, once you have minus here, so you have to make it positive. And just once you get value here, just put it in the column form, and this is your lambda. Now for what was our other lambda? It was it's 3. Now for lambda is equal to 3. The same lambda, sorry, a minus lambda, let me write it neatly. Matrix A minus lambda into I is equal to 0. I will direct now put it in the matrix. 2 minus 3, 1. 1, 1, 2 minus 3, x into y is equal to 0. Next, just solve it. Minus 1, 1, 1, minus 1, x into y is equal to 0. Now put it in the equation form. So this is minus x plus y is equal to 0, x plus minus, so it will become x minus y is equal to 0. This is your equation 3rd. This is your equation 4th. So again you have to take any equation. Okay, let me take the first one. Minus x plus y is equal to 0. So once you move it, so it can become x, y is equal to x. We can get this equation, and now you know that both have 1, so your x and y is equal to 1 into 1. So what you can write, your final answer, your lambda is 1, your another eigenvalue is 3, your eigenvectors for x is equal to minus 1 into 1, and your eigenvector for y is equal to 1 into 1. So this is your answer. Just you need to uh, keep the step in mind. It's not difficult, it's very easy. You know those all determinants and all of stuff. We are doing it again and again. So what you are doing it, first we are finding eigenvalues, then we are finding eigenvectors. So this is one example which I took, and this is the equation. This equation is called characteristic equation. So this is the characteristic equation for eigenvalues. So what you need to do is just put the matrix A, then lambda, then identity, simplify it, you will get here, then find the determinant. When you reach here, you know the determinant also. This will become cross multiplication like this, and you will get this value. Now this is the main part when you are finding the values. So you have to be very careful here that how you can simplify once you reach here. So then you have to do factors. You have to find one number. When you multiply, you will get 3, and when you add or subtract, you will get the middle value, which is 4. So these two values from there I got. So these are my eigenvalues. Then when you have eigenvalues, you just need to find eigenvectors, and in the same characteristic formula you have to just put the values. So now we have 2, 1, 1, 2, the same everything, and lambda will be put here, which was 1. Once we simplify, we get this matrix xy, then we put it in the equation xy, and once you put it in the equation, you will get we got here minus, so this we have to make it positive coefficient. So for that we multiplied and divided by -1. So let me write here. Because we have to make both coefficients, I have a right. Both coefficient values has to be positive. So we divided by -1 here. Then just put the values. So this minus minus will cancel with each other. Now xy, and this is the value. For x you got this, for y you got this. Put it in the value. This was for lambda 1, and then for lambda 2 again put all values in the equation, and here you have nothing, so which means we have 1 here. So these are the final answers you have. So it's easy, don't be confused that how it's work, because just you have to keep steps in the mind, and then you will solve it, that how it works. I'm writing one example for you here. It's again 2 by 2. You just need to practice it by yourself. This is matrix 4 1, and this lecture I'm recording for all 6 sections, so then no one can say that we did by this method or this method or this, so for all it will be same. This eigen chapter will be same for all 6 sections. So this we have to find again eigenvectors and values. First you will find values, then you will find vectors. Once you solve it, you will solve it. I'm just writing the answer. You will get here 5 and this is 2. So practice on it as much as you can, because there will be a question in exam from it, so you have to do it. And your eigenvectors will be vectors for lambda 1 is 5 is equal to, you will get 1 1, and for lambda 2 is equal to, you will get 1 minus 2. This is your final answer. Now we will move to the complex matrix, which is 3 by 3, so you have to listen it very carefully. It will be lengthy because it's 3 by 3. So example 3 by 3 matrix. For example, I have a matrix A and the values I have 1 1 3 1 5 1 and 3 1 1. Steps are same, solution, but just to, it has more values now. Solution, so we can say that again same characteristic equation, which is A minus lambda I is equal to 0. This is your matrix A 1 1 3 1 5 1 3 1 1, and matrix I is equal to identity 1 0 0 0 1 0 0 0 1. Now you have to apply the formula. So what you will get, you have to multiply lambda here with this one, so this will become lambda. So you can write here also lambda into identities 0 0 0 lambda 0 0 0 lambda. So it will become like this. Now you have to put in this formula, so you have to minus it in the same for the upper one, for the 2 by 2 matrix, but now it's 3 matrix, so 1 minus lambda, here is 1, here is 3. Close matrix, here is 1, here it will become 5 minus lambda, here is 1, here it will become 3, here it will become 1, and here 1 minus lambda, which is equal to 0. Now, what will be our next step? What was our next step, if you remember? Our next step will be take the determinant. This determinant will not leave us in this linear algebra. So now we will take determinant, which is equal to, you remember this one will go outside, 1 minus lambda. So this matrix and this matrix, this column and this row, you will hide, so what's left? 5 minus lambda 1, 1 into 1 minus lambda. Now for the second one it has to be minus. You all know these. So now we are in second column and first row. So second column, first row, once you hide it, what's left? 1, 1, 3, 1 minus lambda. So this is 1, this is 1, this is 3, 1 minus lambda. Now these are like this, plus, minus, plus, and then minus, plus, minus, plus, minus, like this. So now the next one is plus. We have 3 here. So third column, first row, 1, 5 minus lambda, 3 into 1. 1, 5 minus lambda, 3 into 1. Right. So now, step by step, you have to simplify it. If you do all together, you will get confused. Now let's first do it for this one. So we will keep this same and we will multiply. First we will simplify inside the equation. So what we will get? 5. What we will get? 5 minus lambda into 1 minus lambda, and 1 into 1, so minus 1. Bracket close. So this equation will become what? 5 minus 5 lambda minus lambda plus lambda square minus 1. Now again we have to write this one here. Only these inside, in the brackets inside, we multiply and we simplify like this. So here we can mention that combine the likes number. I mean likes mean 5 into 1 like this. So these are likes number. So we can mention that 5 minus 6 lambda plus lambda square minus 1. You will get like this. Then you have to rewrite in standard form as we did for the previous also. This will remain the same. You will solve it in the end. So once you move it in the standard form, it will become like this: 6 lambda plus 5 minus 1. Now just multiply this lambda inside. We can also simplify it a bit more. This one we can also solve it. So you can write here lambda square minus 6 lambda plus 4, because 5 minus 1 become 4. So now multiply this with this one inside. 1 minus lambda into this lambda square. So what you will get? Lambda square minus 6 lambda plus 4 minus lambda cube plus 6 lambda square minus 4 into lambda. Now once you simplify it, and high power always come first, so you can write here minus lambda cube plus, you can go there, 7 lambda square minus 10 lambda plus 4. So this is for the first one. This was only for this one. Now for this and this. And then you will combine it at the end, you will get the values. Now for the second one, which was minus 1, 1 into here, minus 1, 1 into 1 minus lambda and this one. So it will become multiplying. So 1 minus lambda minus 3 into 1. So minus 1 will still remain the same. Minus 1 can become, so minus 1, once you solve it, so it can become 1 minus lambda minus 3, and we can say that minus 1 into minus lambda minus 2, which is equal to lambda plus 2. This is another one. Now for the last one, three into 1 into 1 and this lambda. 1 into 1 and 3 into 5 minus lambda. So now 3 into 1 into 1 minus 3 into 5 minus lambda, which is equal to 3, 1 will become 1, 15, 3 powers are 15, 15 plus 3 lambda. Now what we can say, this is 3 into 3 lambda minus 14, and we can say that this become, once you solve it, it will become 9 lambda minus 42. This is the third one. Now what you have to do it, just you have to put all together. Once again, okay. Now this will become minus lambda cube plus 7 lambda square plus 10 lambda plus 4 plus lambda plus 2, this one, and plus 9 lambda minus 42. Again the same story. Combine like terms or numbers or whatever we say. So we can say that we can combine this one minus 10 lambda plus 9 lambda, which is equal to 0. Then what's left? We have 4, we have 2, we have 42. So we have 4 plus 2 minus 42, which is equal to minus 36. And then what's left? We have minus lambda cube plus 7 lambda square we have left. And we have minus 36 is equal to 0. Now we have to remove this minus, so we can say that multiply by -1. So this will become cube 7 square plus 36 is equal to 0. Now you got this equation here, and once you got this, don't be confused on this. Once you solve this, you will get 0. Once you solve this, you will get 36. So what's left here? These two values only left, and this is 36 left from here. So just put this is an equation and you'll solve it. Maybe you are thinking that what's happened to this equation. So once you solve it, it becomes 0. And this 4 left, 4 plus 2 minus 42 is here, so it's become minus 36. So this one like already solved. Now what's left in the equation? These two only left with us and 36. So we put it in one equation, and we want to make it positive here, this coefficient. So we multiply with -1 and we reach here. Now once you reach here, what we need, lambda 1, lambda 2, and lambda 3. We need the values for we need eigenvalues. So what we can do, here we have to find one factor. Here, keep in mind, we have to find one factor once which you put it in this equation, and you can get the value 0. So did you get my point? You need that type of value here. Once you put it in that equation, you multiply and you get 0. So here, once we put this value in the equation, so let me solve it. Cube minus 7 3 square, this equation, plus 36. So once you solve it, this is 27, 63, 36. And once you solve this, you will get 0. You will get 0. So we solve it here. Now we get the value for the lambda. Now we can solve our equation. So we can say that lambda cube minus 7 lambda square plus 36, which is equal to, now again, and this is the same value, if you multiply and add, you will get the value here. So square minus 4 lambda minus 12. Four minus 3, 7. 12 into 3, 36. Did you get my point? So just simplify it a little more, so we can reach to the values of, so this is our final equation now, x square minus 4 into 12. Now what you need here again, if you multiply, then you can get this value. If you add or subtract, then you will get this value, which we call factors. Factors are very important in this eigenvalue. So how you will do it? Again, lambda minus 6 and lambda plus 2. 6 into 2, 12, and when you subtract or add them, you will get 4. And the other one, you know it, we already took, lambda is equal to 3. So what you can say that our lambda 1 is equal to 3 and lambda 2 we have is minus 6 is equal to 0, so you can say that lambda 2 is 6 also, and we have lambda 3 which is plus 2 is equal to 0, so you can say lambda 3 is minus 2. So now we have all of them. Lambda 1 3, lambda 2 6, lambda 3 minus 2. What you need to do is, next step is vectors. Next step is eigenvectors. So just you need to put values in the formula and you will be done. Characteristic equation, lambda I x is equal to 0. We have lambda is equal to 3. And I will write my matrix which was 1. We have 1 here, we have 3. We have 1, 5, 1. And we have 3, 1, 1. We have x, y, z is equal to 0. Now, again, for lambda is equal to 3, and you know that now this you have to multiply with identity matrix, so again it will become 1 minus lambda 1, 3, 1, 5 minus lambda 1, 3, 1, 1 minus lambda x, y, z, which is equal to 0. So just put value of 3 now. 1 minus 3, 1, 3, 1, 5 minus 3, 1, 3, 1. So this is 1 minus 3. And you have x, y, z, which is equal to 0. Now simplify it again. What you will get? Minus 2, 1, 3, 1, 2, 1, 3, 1, minus 2. You will get here x, y, z, which is equal to 0. Now if you remember, once we reach here, we put them into the equation, same we did previously. So this is minus 2x plus y plus 3z is equal to 0. And this is x plus 2y plus y plus z is equal to 0, and this is This is 3x plus y minus 2z is equal to 0. I mean, you can take any two equations to solve it. It's up to you. Answer will be same for all of them. I will check here 1 and 2. And I will solve this again by this cross multiplication method. And if you write it in this way, which I'm writing, so it will be easy for you, you will not get confused. For example, we have here x, y, z. Just put it like this, x, y, z, x, y, z. For the first equation, what is x? X is minus 2, this is 1, and z is 3. For equation 2, what is x? X is 1, here is 2, and here is 1. 1, 2, 1. Now I'll close this one. Okay. Now I have to do cross multiplication. Now I'm finding the value for the x. So when you want to find the value for the x, how you will do it? Let me make it like this. Okay. Just 1 second. Once you want to make the value for x, so you will hide x. I mean, let's say put your hand on x. What left? 1, 3, 2, 1. You will write here 1, 3, 2, 1. Now you need y, but you have to start from the right side. So you can hide y. What's left here? 3, minus 2, 1, and 1. Put on the z, what left with you is minus 2, 1. This is 1 into 2. So keep this in mind. Then these two values will same. These two values has to be same, and these two values will be same. If they are not same, so it's mean you did some mistake. So keep this point in your mind. Now, just I have to make it simplify. So now for x, y, and z. Okay, cross multiplication. One into 1, 2 into 3, 6. 1 minus 6. For y, 3 into 1, 3. And this is minus into minus 2. For z, we have minus 4, minus 1. Simplify it more. So we have x over minus 5. We have y over 5, and we have z over minus 5. So x, y, z, we can write here minus 5, 5 minus 5. Now, what we can do with it? So we can take out 5 common, 5, or we multiply with 5. So is minus 5, 5 minus 5. It will become what? Minus 1, 1 minus 1. Let's simplify a bit more. We have minus, so further it can, and it's a scalar multiple, so let's say multiply with minus 1 also, so we can get 1 minus 1, 1. So this is for lambda is equal to 3. Now we are good enough to go to the next one. So now for lambda is equal to 6. For lambda is equal to 6, I will write here the same step you have to do. These are just from this matrix. Instead of 1 minus 3, now you have to do 1 minus 6, 1, 3, 1, 5 minus 6, 1, 3, 1, 1 minus 6. So I will write here matrix directly. I can write here minus 5, 1, 3, 1, minus 1, 1, 3, 1, minus 5. Same a minus 1 equal x is equal to 0, x, y, z is equal to 0. What you need to do is put it in the equation. Minus 5x plus y plus 3z is equal to 0. And then the next one, x minus y plus z is equal to 0. And the third one, 3x plus y minus 5z is equal to 0. We have 1, we have 2, and this is equation 3. I will take only two equations, 1 and 2. Let me solve it again. Again, we can make x, y, z. And this once we separate, so it's easy for us to solve it again. First two, so this is minus 5, this is 1, this is 3, and this is 1, minus 1, and this is 1. Okay. Now, I need the values for x, y, z. X, y, z. So hide x, you will get 1. 3 minus 1, 1. Hide y, you will get 3 minus 5, 1, 1. And when you hide z, you will get minus 5, 1, 1 into minus 1. Now we have x, we have y, and we have z. Cross multiplication, 1 into 1, 1. Minus into minus 3. 3 into 1, 3. Minus into minus 5. This is 5 minus 1. So you will get x over 4. You will get y is 8 and z is equal to 4. So your x, y, z become 4, 8, 4. And you can see it, we can solve it more. So we can say that let's make 4, 1, 2, 2. For 2s are there, for 1s are 4. Sorry, this is 1. This is 1. So this is for lambda is equal to 6. Now what's left? The last one, which is lambda is equal to minus 2. Now for lambda is equal to -2. So once you solve it and when you put the values in this equation, now you know it's very easy. So you will get this matrix 3, 1, 3, which is 1, 7, 1, 3, 1, 3. And this is x, y, z is equal to 0. Now put it in the equation form. 3x plus y plus 3z is equal to 0. We have x plus 7y plus z is equal to 0. We have 3x plus y plus 3z is equal to 0. Again, we can check these two equations. Let's make our table. X, y, z. We have 3, 1, 3. We have 1, 7, 1. Now I need values for z, y, x. So hide x, you will get 1, 3, 7, 1. Hide y, you will get 3, 3, 1, 1. And hide z, you will get 3, 1, 1, 7. And these are all same. It has to be same. If it's not same, you did mistake. Now the next step, x, y, z. 1 into 1. 1 minus 21. 3 minus 3. 21 minus 1. So x over minus 20. Y 0. Z 20. X, Y, Z. What you will get? Minus 20, 0, 20. So can we do it like this? Minus 1, 0, 1. And this is for lambda is equal to minus 2. So we can say that lambda is equal to 3, you get matrix 1 minus 1. When lambda is 6, you get matrix 1, 2, 1. And when lambda is minus 2, get minus 1, 0, 1. So this is your answer. Now, once you reach here, important thing you have to keep in mind that once you reach here, and in the question, if it's asked, find the eigenvalues and eigenvectors. So until here, it's fine. I mean, until here is your answer. But if it's asked in the question that find the diagonalization of this matrix, so then you have to do more steps after this also. If it's asked find the eigenvalues and eigenvectors, tamam, until here is fine. But if they ask this one, Diagonalization, diagonal. Diagonalization. So then you are not finished here. Okay, for the same questions I'm doing it so you will understand. But you have to do it for this one. For diagonalization, there is one formula in the book you will see, which is D into P inverse A into P. You have to prove this. So D is the diagonal matrix you will find. P is your lambda 1, lambda 2, and lambda 3. And A is the matrix given in the question. A is the matrix given in the question. So let's put the values here. Matrix P, which we got just now, we got here 1 minus 1 1, 1 minus 1 1, then 1 2 1, 1 2 1, and for lambda 3 minus 1 0 1, minus 1 0 1. Okay, this is your matrix P. Okay, now what is your matrix A? Your matrix A was 1 1 3, 1 5 1, 3 1 1. Now here if you see, it's mentioned here P inverse, and you knew it how we can find P inverse, A inverse, P inverse, etc. So if you remember what was inverse, on our determinant is P, so we write P here. Determinant of P into adjoint of P. And you remember all the steps. First determinant, then cofactors, then adjoint, and then take inverse. So all the way you have to go. So once you calculate P inverse, you will get P inverse. Your determinant you will get 6, and the matrix you will get here minus 2. I'm writing direct. You have to do it. Because so many times we solve this inverse and determinants again and again. So you have to practice on it. And once you, for example, this is your matrix for inverse. Now the formula is D is equal to P inverse A into P. So now you need D. D we have to find. P inverse, this is your P. 2 minus 2, 2, 1, 2, 1, minus 3, 0, 3. A is the main matrix, which is 1, 1, 3, 1, 5, 1, and which is 3, 1, 1. And P matrix, which are the answers of our eigenvectors, 1 minus 1, 1, 1, 2, 1, minus 1, 0, 1. So you have to multiply all of them to each other. And once you multiply it, you will get your diagonalization matrix 3, 0, 0, 0, 6, 0, and 0, 0, minus 2. And if you remember, these diagonalization are your eigen values. So it means your answer is correct. Now, let me give you another. If you want to get rid of, if you want to get rid of this inverse, how you will solve it? Because this inverse will take a lot of time from you and you will get confused and all those stuff. So in the book is mentioned also that AP is equal to PD if their answers are same. So it's mean it's correct. Your D is correct. So how you will write D then? Before here you will write D. Now you will be thinking that how I can get D, because for D I need to solve by inverse method. Now how you will get D? You have to come here. Go. This is your D, minus 2, lambda 3 minus 2, lambda 2 is 6, and this is 3. So you have D matrix already, you solve it. So don't be confused that I didn't find inverse of a matrix, how I can get D. So this is how you will get D. Your D is lambda 1, lambda 2, lambda 3. Your D is, if you want to solve by this method, then your D is lambda 1, lambda 2, lambda 3. So your D matrix will be what? 3, 0, 0, 0, 6, 0, 0, 0, minus 2. Okay, now let's prove this. AP, A was your main matrix which was given to you, which is 1, 1, 3, 1, 5, 1, 3, 1, 1, which is, and now you have another matrix P. P is the same matrix you get from the vectors 1, 1, 2, 1, minus 1, 0, 1. Multiply them. Once you multiply them, you will get this matrix 3, 6, minus 2. So minus 3, 12, 0, 3, 6, 4. Okay. Now this one was for what? AP. What next we need? PD. PD is equal to what? P is this matrix. Again we have to write here 1, 1, minus 1, minus 1, 2, 0, 1, 1, 1. And D is this one 0, 0, 0, 6, 0, 0, 0, minus 2. These are 0, don't make them 6. Multiply them and you will get the same matrix. Then you multiply them, then add them, you will get the same matrix. So 3, 6, minus 2, minus 3, 12, 0, and 3, 6, 4. So which means AP is equal to PD, and this is your answer. Did you get my point? Okay, let's start from the beginning so you will not get confused. Okay. Yes, it's lengthy questions. It takes time. But you need to practice a lot so you can solve it easily. Okay. From here we started. 3 by 3 example. So this is one given matrix. All the steps are same. We did it in the 2 by 2 also. The determinants is a bit long. So my suggestion is don't multiply directly in the beginning this, then you will get confused. Try to simplify as much as you can and then do it like this step by step. So you will reach to one point, and once you reach here to this type of equation, so then just make it factors and you will get the values for your eigen. Once you have eigenvalues, then you need to find vectors. How you will find vectors? Just put it in this characteristic formula. You have your main matrix, and that matrix value you have to just multiply. Now you have value for the lambda, so just put lambdas in the matrix and you will get the values. So once you reach here, you need to just put it in the equation. If it's -1, so then you have to mention minus. If there is no any minus, so just for 1 you don't need to mention anything, just plus x, y, z. So if you look at this equation, this is -2, this is 1, so we can write y, and this is 3, so we can write z. So then for the second one, this is 1, so we can write here x plus 2y plus z is equal to 0. Then 3x plus y minus 2z is equal to 0. Then you need to take two equations and use this method. This is very easy method. So just put this value for x, y, z. This is -2, this is y is 1, and this is z is 3. So then what you need for the second one, so you will get 1, 2, 1. Now, if you look at here, now you have to make them small matrices because you need to do cross multiplication. So just hide x. For y, z values your x. So 1, 3, 2, 1, same for y, same for z. And then simplify x, y, z and put it in this cross multiplication. So 1 into 1, 3 into 6, 3 into 1, 2 into 1, 2 into 2, 1 into 1. So once you get here, just put it into x, y, z, and it's simplifying more, so simplify as much as you can. So then it can be easy for you by the end of the matrix. Then do for the 6, for another lambda. This is 2. This is 1. And once you do it for the 2, all the procedure is same. And this is for 3. So once you do it for all of them, and you will write here for a lambda 1, 3, this is my eigenvector. For eigenvalue of 6, I have this eigenvector, and eigenvector for eigenvalue -2, I have this vector. So again, the important point, if it's asked in the question that find the eigenvalues and eigenvectors, stop here. You are done. And if it's asked that find by the diagonalization, so then you have to come here. Keep this formula in your mind, P inverse A into P. So here they said that if you want to get rid of the P inverse, they are saying that P inverse is equal to AP into AD. It's up to you if you want to find my P inverse, but the value for the P is the value for the eigenvectors. Is P matrix. A matrix is the matrix which will be given in the question. And if you want to do by this method, you are most welcome. No problem. It's up to you. Answer will be same for all of them. That will take time. So that's why I just show you that if you want to do by inverse method, it's like this. And your answer will be this 3, 6 minus 2. And then if you want to get rid of this P inverse, so then use the other formula. And your D matrix will be the value for you get from the, because if you're solving another example, so don't get confused that where is my D matrix. Your D matrix will be your value lambda values lambda 1, lambda 2, lambda 3. So these will be your values for the D matrix. D is the diagonal matrix. So then you just have to show them that AP and this PD, they are together. Sorry, they are equal. So once you reach here, so it means your answer is correct. Okay, but it's very easy, but just you need to practice. If you didn't practice, so you cannot solve it. Practice can make you perfect. If you are not practicing, so then it's very hard. You cannot learn anything. Let me write an example for you. You have to solve this. Normally if I'm in class, so I just give it in the class, so students solve in front of me. So, but now it's online, so let me write for you. You have to practice on it. And this is bonus marks in your exam. Find eigen values, eigen vectors, and diagonalization. So for all of them you have to solve. Solution, your eigen values is this one. Let me write for you. So once you solve it, compare it. And your vectors will be, your eigenvectors will be, let me check here, your eigenvectors will be, for this one 1, 2, 2, for this one is 2, 1 minus 2, and for this one is 2 minus 2, 1. And your D matrix will be 0, 0, 0, 0, 3, 0, and 0, 0, 15. Look, they are matching. So this is your answer. So practice as much as you can. In the coming week, we will also discuss some other topics on this eigen, its orthogonality or some transformation, etc. And then we will move to the last 2 weeks. Total last 3 weeks, but normally in last week we are doing revision. So we will do only 3 more topics and then semester will be finished. So practice as much as you can. I'm saying it from now, this is in the exam. And it's very clear. Everything is very clear. Just these areas need your basic mathematics. It's not very complex. So just you need to focus on it once you are solving it. Okay. So you will finish it here. Take care of yourself. I hope once you watch this, you will learn something and it will be very helpful for you.